Hi there, this is Ted M. Young, also known as JitterTed. Welcome to the KidBank app development, the money tracker for kids. This is episode 2, the refactoring, where I refactor classes into the Hexagonal Architecture and then refactor the current account's balance tracking to use Java streams and sum over the transactions. Enjoy! Last time we completed the spend money story. The app is still up and running, and oh, I guess I didn't stop it, so it still has the transactions from last time. Okay, so on today's agenda is some minimal responsive styling work. I keep pushing it off because I am barely capable of doing front-end stuff, but I'm going to push that down a bit because really what I want to get to is importing a CSV to pre-populate the account. Where that comes from, so this is currently my layout for keeping track of Asher's money. And so what I want to be able to do is basically take these transactions and load them up into KidBank so I don't have to retype it. So let's hide that for now. So that's what we're going to do, is we're going to basically import the CSV to pre-populate the account. Check where we are here. So all unit tests. So for some, oh, I know why. So what happens is in IntelliJ, if you make some of the changes here, but I don't know if you can see it, but basically these icons are grayed out. If you don't save them, basically it uses a least recently used and then it gets rid of them. So I had defined 3 kinds of test running. One is for all unit tests, right? Those will run in less than a second. So let me save that. Then I had one that is basically all the tests, no matter whether they're in the unit test directory or the integration test directory. So I've got 2 places where I keep the integration tests. One is under integration tests, which is a fairly standard place to put integration tests, those that are going to run everything and take a little longer. And then further down here, let me close this. Further down here, these are the unit tests. So I have a configuration to run all unit tests, but I want a configuration to run all the tests. So this is basically all tests. And let's save that. And then I want to have one that's for running all of the integration tests. So I might just, let's see, so if I run these, I think it's going to run all of just the integration tests, which is what I want. So what we'll do is so this one is running the integration test. So these are all integration tests. And we'll save that. That's saved. Then we want one that is, so I'm just going to, so that's all unit tests, all integration tests. And then I basically want to run all tests. Oops. So this is going to run all unit tests, so maybe I'll just manually make a configuration. So I'll duplicate this one. And this is going to be all tests. And this is going to be all in package. And so that will basically make it, no matter where it is doesn't matter what directory it's in, we'll just say in a whole project. We don't have modules, so that's fine. And so that way we have 3 different predefined ways to run tests. All integration tests, all tests, and then all unit tests. Let me just check the application. This one needs to be saved because that's what we'll run. These unknown ones I'll just delete. Okay. All right, so now we're all set up. Nothing to commit. Let's run all the tests just to be sure that everything is working. And there we go. All tests pass. Great. Okay, so our story, as I mentioned, is we're going to import a CSV to pre-populate an account. You know what? Before I do that, I wanted to do some refactoring. So let's do that. So right now I've got basically all of these classes. They're just in the KidBank package. But let's start splitting them up according to the basic architecture that I'm using. So for those of you who aren't familiar with that, I have my ports and adapters hexagonal architecture diagram. And so the idea, if you're not familiar with this architecture, is that you have a central core, which is your application and holds your domain model, your business logic, all the stuff that's specific to the logic of the application. But then any communication with the outside world, whether it's sort of incoming through a web app or some phone app or maybe some other machine, that's all in these adapters. And there are two different kinds of adapters. They're what are called the primary or driven adapters. These are ones that are initiated by some incoming request. So like a web page or a phone, that would be an incoming request. Then there are what are called what I call reacting or secondary adapters. And these are things that are driven by the application. So for example, the application, if it wants to persist something, when we get to that, we're going to use a persistent storage adapter. If we wanted to do some external notification, which is on the list, to send out an SMS or some other notification, that is driven by the application. So the driven ones are the primary ones. I'm not terribly happy with this naming convention. As I've talked about it, I've been searching for good terms, but as we know, naming is hard. So these are the ones. These blue ones are the ones that are incoming. The sort of yellow ones are the ones that the application itself pushes out. So typically the direction is something in the application causes it to talk to one of these, like maybe a payment adapter or writing out to some database. Okay, so what I want to do is I want to move these now to the correct part of the architecture. So anything in the domain, I'm going to move to the domain package. So that goes into the domain package there. Transaction is also in domain. And account controller is in an adapter, specifically a web adapter. So my naming convention that I've used is I'll have domain and everything in the domain in there. Then I'll have an adapter subpackage, and then subpackages from there to be used for each individual adapter. And sometimes you'll have shared things across adapters, like the formatting or the command stuff is things that might be shared across adapters, and those will be up in sort of the generic adapter package. So let's move that there. Transaction view is also adapter web. This is the entry point into the application. Oh, that was something I don't need. Oh, wait. Yes, so I'll have to come back to that. Transaction command is also adapter web. And let's see what else. And date formatting and scale decimals, those are also adapter. right now they're only used by web, but we might share them later. And so what I also want to do is move the tests to associate with the correct package. And you can tell basically here I'm importing from domain, so that means this should go to domain. And I can just say domain here, and fix that. Balance, that's working on domain. Deposit, spend, so all of these also go into domain. And these are accessing the web adapter, because these have to do with how the transactions are viewed. So these go into the adapter web. And, oh crap, I think I hit a wrong key here, so these got moved out of the test. I make that mistake a lot. So, all right, so this and this are actually in here. So they need to go into adapter web, but they need to actually be in test. So let's do that. You can always tell, oh, that messed up. Darn it. So now I got to re-static import this. Or I can actually just do that and do roll back there and roll back there and optimize my imports. Okay. So let's try that again. So these also go into adapter web. And this time I'm going to check the target destination directory. For those of you who are not colorblind, this is a slight green shade, so that tells me that that's tests. Count transaction test is not in the right place. And then these balance, deposit, and other tests also go into domain, also in the test directory. Okay. So let me go clean up, because sometimes the imports, as you're moving stuff around, get messed up. All right. I'm going to run all the tests again. And while it's doing that, I'm going to do a commit to basically reorganized packages to Hexagonal Architecture. And yeah, another case where that happened. And re-import that because the imports got messed up. Build again. I should have built before I committed. So let me run the tests again. I'm actually just going to wait till the tests run before I commit, just to be sure. And I'm basically going to amend that commit. All right, so we'll commit that. All tests pass. Great. So that was a dev task. Let me clean you up, logs. And cool. All right, so now if we look here, we see that stuff is nicely organized into packages. So our domain is pretty small, right? We've got an account, and account has a bunch of transactions. Our web is dealing with producing the web page and interacting with it. So all of the controller formatting for human consumption and the transaction command that come in from the posts those are all in our web adapter. And so you should always be able to tell if you've got your stuff in the right place, is I should be able to completely delete anything in any of these adapters, and not only should the core domain still work, mainly all its tests should work, but any of the other adapters that I have should, if I have them, should remain working. So there's no dependencies between adapters, and as you can see with the arrows, all the dependencies are inward. So adapters can depend on the domain, but the domain should not depend on the adapter. So if you look close up at that, this is what it looks like. The dependencies always go inwards. So your component, your domain logic is in the center, and things always depend inward. These slides are from a talk I gave at Silicon Valley Code Camp this past October. The slides are up on my website at tedmyoung.com. So it was all about ports and adapters. All right, so we want to pull in the CSV spreadsheet for preloading the transactions. So what that basically means is that we want to create an account and then basically do a bunch of deposits or spends depending on what the transaction is. So that might be a little inefficient, so it might be nice if there was a way to directly instantiate account with a given set of transactions. We currently have transactions as an immutable set, and then what happens every time we add a new transaction, we basically copy over the old set and then tack on the new one. And so for sort of one at a time, that's okay, but for sort of bulk loading, it would be nice to completely replace the list of transactions. This might get tricky later when we try to hook it up with some persistence, but for now, let's see where this goes. One thing I'm thinking about is there's another refactoring. You know what, I want to get the refactorings out of the way. So there's a refactoring that I wanted to do, which is right now, balance is kept separate, and so there's sort of duplicate work going on. We're basically, every time we do a deposit, we're adding to the balance, and every time we do a spend, we're subtracting from the balance. But that's really redundant because we have the transactions, and so we can run through them. So it's sort of like a journal, right? So we can run through them and get the same amount. So what would be interesting, and sort of the direction I wanted to go anyway, is to not store balance separately, is to have the balance always rely on basically summing up the transactions, because it's not like it's going to take all that much longer. Sure, even if I have 100 transactions, but come on, transmitting the information over the web page is what's going to take the time, not the running through the transactions. So one thing we can do is we can basically change this. So we do transactions, and we do a stream, and then we do, so the stream is going to give us a bunch of, the stream is going to give us basically a bunch of transaction objects. And so on each transaction object, what we want to do is we want to pull out the amount. So this is interesting. So we want to pull out the amount, but the amount isn't enough because we need to know what type of transaction it is in order to know whether we're going to subtract that amount or add that amount. Because the amount is always a positive amount, but obviously a spend needs to lower the balance versus a deposit, which needs to increase it. Because we could just do map to int. So that'll basically, so we can say transaction and then amount. So what this will do is it'll now give us, it'll go through each transaction and basically extract the amount. And so the amount is an int. right? That's an int, correct? Yes. And so then what we can do is we can do sum. And so now we have basically summed over all of the transactions, basically pulling out the amount and then summing it up. Now, my guess is we might not have good test coverage for this. So let's undo this for a second. And let's go into our deposit test. So we have a deposit test that has 2 transactions. So that's good. So that we'll make sure that we are not just returning like the last transaction or something like that. Let's look at the spend test. So we want to write another test for this where spend money twice should reduce account balance by sum of all spending. Okay, so same thing, we can do account, and we'll new one up, and we'll put that in a variable, and then we'll say account.spend. I'm actually going to just copy this. So change the date a little bit, change the amount. And then I'll change the date a little bit more, and I'll put in a different amount. Make this $300 even. So now I can assert that the account balance is equal to, and so this should be, since we're spending money twice, it should be basically negative $37.95. And if we run all unit tests, this one should pass because and of course I can't add. That's why that failed. Usually I do that on purpose, like I'll make the test fail even though I might have the functionality. And this is where I guess I kind of differ from other TDD folks that, no, the test must fail. But that's a discussion for another day. Okay, now what I'd like is sort of one test that does a mixture of both. So here in our balance test, we can do that. Mixing deposit and spend should result in correct balance. I go back and forth with naming some of these things. Like sometimes I'll use very concrete amounts, like mixing deposit of $10 and spend of $15 should result in $5 balance. So it sort of depends on how I'm feeling, but I'm going to be specific here. So we're going to say deposit 17 and spend, let's say 9 should result in 17 minus 9 is 8. And 8 balance of 8. So copy that over, copy account creation. So we're going to spend, we said 9, which is 900. Call that cards. Do a deposit. And I'll change this date again. And this is bottle deposit because my son likes to drop off the bottles to get his money because we go to the local recycler. And let's say this was somewhere in May 1st of that year. Okay, so we assert that account balance is equal to, I know I said 8, but let's make this test fail. And Oh, that's right, it's a scaled integer, so it actually needs to be 800. So now if we run all the tests, they all work. Okay, so we've got a bunch of tests that do multiple transactions. And so now let me go to account. Okay, so we now have tests that feel like cover it. So now we're changing the implementation. So this is changing internal behavior, but external behavior, it shouldn't change. So this is sort of a true refactoring. We've encapsulated how we're calculating balance, and nobody else outside should care how we did that. So we'll go to transaction stream, and then we'll map to int, and we're going to do that by doing transaction amount. And then we're going to sum that up. And I expect stuff to fail because, as I mentioned before, we're not looking at whether these transactions are deposits or withdrawals. So let's see which tests fail. All right, so this spend command should reduce amount in account. That's right, because we were ignoring the sign, so that's an expected way to fail. That's also expected because instead of subtracting, we added. And the spend test also here. So good, so they failed. So now the question is, this is not good enough in the sense that we don't want just sort of the magnitude of the amount, we actually want its sign. There are a couple of things we can do. We could provide a method that provides on the transaction the sort of signed amount. That might be interesting. And that way we encapsulate how it figures out whether it's a negative or positive in there. So let's do that. So let's go into transaction. So transaction is, one thing you'll notice is that even though I'm using Lombok to generate the equals and hash code and a nice toString, I don't have setters and getters for things like date, action, amount, and source. Because this is not a Java bean. This is not like a data transfer object. This is a POJO. This is a plain old Java object that has behavior in it. And so what I'd like is to have a method here that gives us a signed amount or transaction amount. Not sure what name I'll come up with. So let's go to transaction test. That might help us come up with a name. So this is testing at the account level. So let's go and create a transaction test. So create a new test, transaction test, and we're not going to set up anything. Yes, that goes in that directory. Cool. So our first test that we're trying to expose is that a spend transaction should have negative transaction amount. So if we create a new transaction, and technically I could probably do null for a bunch of these since I don't really care. So I could just put in now because it really doesn't matter. The action, so this is the important part. This is a little bit dangerous because I'm using a string here for the action, which is either deposit or spend. So I'm going to do spend here. And so the amount, I'm going to do 1375. And the source is, I'll just say, source, I think it's fine. And need to do var, supposed to hold that in a variable. So now I want to assert that the transaction so the transaction amount should be 1375. That's straightforward. But I want to have the scaled amount, or the what do I say? The transaction amount seems redundant. Signed amount. I can try that. Signed amount. And that should be is equal to negative 1375. So I don't really need this because I know that amount works. So signed amount, I think, is the name of the method I'll use. I don't know why it assumed it was a Boolean. It's an int, and we'll return 0 because we're going to return, and it would help if I spelled is equal to correctly. Okay, so this test should fail. We'll just run this test by itself. And of course it does. So now this spend thing is kind of tricky. There are a couple of ways to go here. One is if we look at a count, we'll see that it's also using the string here, but that's internal to a count. But feels like this thing should be controlled by, like, who cares about whether it's a deposit? So one thing is it's used for displaying. But the other is now it's going to be used to figure out, is this a positive amount or a negative amount? So it seems like that should go into transaction. So I think what we want to do is, instead of explicitly calling out that this is called spend, is not leave that up to the caller, but create a spend transaction. And so that means whatever the string is, that's encapsulated inside of transaction, and we don't care about it. And this might be a time when we think about moving to an enum, but let's hold off on that. So we'll create a method that returns a transaction. This is the amount, and that's the source. And so what we're going to do is we're going to return a new transaction that has the local date time, and then the rest of the stuff is just copied. This is just about the point where we want to convert this to an enum, but let's actually start by moving this into a constant. And let's see how that name works out. And let's make that private, because we don't care about anybody else having access to it. So let's go back to here. Okay, so this should still fail for the same reason. All we've done is made it easier to create the transaction, and that's cool. Okay, so now we can go here and we can say, well, say if action equals spend, return minus amount, else return amount. And of course, we could simplify this to basically a ternary operator. And there's other things we could do. So right now, this could be made a bit easier to read by replacing it with basically, is this a spend? It's so straightforward, and it's only used inside here that I'm willing to leave it. My tendency is to always remove expressions into their own named thing, but this is so borderline that I'm gonna leave it. Okay, so now actually our test should pass, and it does. So now if we run all of the unit tests, so they're not passing yet. That's okay, because we expected that, because we while we modified and created the signed amount, it's actually not used anywhere. So now let's go back to account where it calculates the balance. We don't want amount anymore. We want signed amount. And so now if we run the tests, I think they should all pass, and they do. All right. So now we've basically eliminated the use of balance, and you can see it's used, but it's never actually accessed. So we can go ahead and get rid of it. And so now if we look at, and just to be sure, I'll run all tests again. And yes, they pass. So now what's interesting is add new transaction is, we're not quite at the point. So we created a creation method, a factory method-like thing on transaction where we could create a spend transaction, because right here we shouldn't really be doing that. So what I think I want to do is another refactoring where I refactor out the creation of this transaction and put it basically back, sort of back here. So let's see, what's the best way to do that? I think the best way to do that actually is re-inline both of these. So I'll do an inline all and remove the method. So now we're back to here. And so now I can pull out this thing into transaction spend. And now I can replace this with transaction create spend. And I no longer need to pass this in. So my goal here in the refactoring that I'm doing right now is I want to get rid of these strings that define sort of the type of transaction. I want to encapsulate that further, even though it's nicely encapsulated inside of account. I want to encapsulate it further because really it belongs to the transaction. So now we've got create spend, and so that's nicely encapsulated. And what I'd like to do is do something similar. So if we go to here, I want to have another one that's basically the same thing. So first let's pull this out into a deposit, and then we can do create deposit, create that method. We're not going to need that, so I'll delete that in a second. And so from here, we can basically just say new transaction, and I'm going to do it this way so that I can do a refactoring. And what I can do is convert this to a constant and get rid of this because we don't need it. And so one other thing that you may have noticed that I'm doing is I'm using a lot of, even like just deleting a parameter from the method signature. I could have just hit the delete key or selected it and hit delete, but I'm as much as possible leveraging IntelliJ's automatic refactoring, because that means I don't have to fix up somewhere else, right? Because here, when I deleted the parameter, if I just did, oh, let me just delete this text and treat it as text, then when I got here, I'd have to go and delete it from here. But because I actually did a refactoring of remove it, that way it updated all of the code everywhere it's used and just make sure everything is in good shape. So now that I've basically created these factory methods for creating types of transactions, I can actually extract this back into a method and say add new transaction. And this is just going to be transaction. So, oh crap. Okay, so I wish IntelliJ would put this in the right place because that's where it really needs to go. I could inline this. I think that's okay. Trying to figure out which one's more readable. No, I'm going to leave it. Okay. And let's see. So we have refactored this, and now there's no mention, there's no strings here. If we go to transaction, we see that we've, and I'll just convert that to private. We have a couple of these strings. Could convert to enum, but I think I've done enough refactoring now. So let me run all the unit tests. And they all pass. Okay, great. So now I've got account, I've got everything back to where it was. Transaction now has some creation methods for things, and account now basically does a stream with a map to int to basically sum over all of the signed amounts to give us our balance. So let's run all the tests. Should take a few seconds, and then I can do a commit, and they all pass. So this was a refactor to use stream and sum for calculating balance sort of on the fly from all transactions and removed balance variable. And the balance is really, I mean, the balance was actually sort of as a cache, and so we could cache it, but I mean, come on, that is certainly overkill. All right, so I'll commit that.